Okay, ready to go?
Yes.
Okay, so before we jump into today's lesson, I wanted to show you something.
Allen wrench.
Ah, an Allen wrench. Okay, good, right? So we got an Allen wrench. Sometimes it's also called a hex wrench. Do you know why it's called a hex wrench?
It's got a hexagon.
Yeah, it's in the shape of a hexagon. Yeah, exactly, right? Okay, now this is a tool often given to you when you're doing like, building like I got one this summer, came in the set, like I built this little, it was like a storage unit to go with like a nice stainless steel top for out in the barbecue, backyard redo summer, so I had that and I built that and I had this thing, right? But when I was putting together this thing, it came with these screws that were like this long. They were huge, right? And then I had to take this thing and put it in, right? But then there was like plastic all around the screw. So it was like I put it in and I turn it and I gotta take it out and I gotta put it in and turn it and then I gotta take it out and I gotta put it in and turn it and take it out. And again, they were really long screws. Like that's annoying, right? It's a tool. It's just, it's not a great tool, right? But it's a tool. But it would do the job. If I had to do it, I could just keep taking it out, put it in, and turn it, take it out, put it in, and turn it. Yeah? Okay? So that's what today's lesson is. We're going to look at a tool. It may be, well, it isn't. It isn't the best tool, but it is a tool. And so we want to be able to recognize it, right? Like I held this up and I said, what is it? And you said, well, it's an Allen wrench. Well, that's because you know the tool. You recognize the tool. And you know what the tool does. It uses a particular type of hex-shaped screw that I can then put in and turn, and then that's how the tool works, right? Okay, so you're going to learn a new tool today, but it's kind of clunky like this tool, and once we find a better tool, we're probably not going to use this tool again because, well, we have a better tool. Why would we use the clunky tool if we have a better tool, right? But we do need to know the tool because, like, for example, if I didn't know what this tool was, I wouldn't have been able to go down to Home Depot and find a better tool for the job because I didn't know what this tool was in the first place. So we got to know what the tool is first, and then we can go, hey, I wonder, is there a better tool? Could we do this better? And I did actually do it better. I'll show you that at the next lesson, but we'll get there. Okay? All right. So that's how we're going to start off. Now, all right, here we go. Let's talk about the tool. That may not be the most efficient tool, but it is a tool, and we do need to know about it. All right. Here we go. So this is lesson 1.1, part 2, right? Because I'm going to try to line these up with the standards that you're going to be assessed on. So I'm going to try to line these up. But we're going to call part 2 recursive formulas. The recursive formula. All right, so let's talk about what is a recursive formula. So a recursive formula allows us to write an equation to figure out, we'll put this in quotes, the next term in a sequence. I'm going to highlight here recursive formula because that's some language you're going to need to know. Because I'm going to ask you to write me a recursive formula. And when I ask you to write me a recursive formula, you're going to need to be able to do that and know what it is that I'm looking for. And we're going to practice that today. Okay? All right, so a recursive formula allows us to write an equation to figure out the next term. What next term? The one that comes next. That one, okay? In the sequence. All right, so there's some things that we need to know in order to be able to write these recursive formulas and find the next term, whatever the next term is. There's some things we need to know. One, we need to know some term. Can't find the next term if you don't know the term before. You got to find some term, right? We got to know a term, right? Now, usually, the term that is used is the first one. Or A sub 1. So we can use any term in our recursive formulas, but most often when recursive formulas are written, they're written with the first term. So that's the first thing. We got to know what the first term is, and then we can write the equation that helps us find the second term. Now, the other thing that we need to know is the common difference / ratio, because we can do this for both arithmetic and geometric. So if we have a term and we know the common difference of the ratio, then we can write a recursive formula, which is basically a mathematical formula that allows us to find the next term. If we start with the first term, then it allows us to find the second term. But if we start with the second term, it'll allow us to find the third term. If we start with the third term, it'll allow us to find the fourth term. If we start with the fourth term, will it allow us to find the 115th term? After we find the fifth term and the sixth term and the seventh term and the eighth term and the ninth term and the 10th term.
That's why it's not that great of a
In turn, take it out. In turn, take it out. In turn, take it. Boy, that's just not a whole lot of fun, is it? But it is a tool, and we do need to know it. Okay. All right, good.
Maybe that would be something special.
That would be helpful, wouldn't it? Okay, so let's talk about what does an arithmetic recursive formula look like. Okay. So there are two parts when you write recursive formulas. There's two parts that are needed. Okay. So the first part is needed is some term. We're going to say the first term. Okay. And so in here we'll just do a little note and we'll say the first term would go in here. So it's going to be A sub 1 is the first term, whatever that number is in the sequence. Now the second part is the formula that allows us to use that to figure it out. And it is A term is the previous term plus the common difference. The third term is the second term plus the common difference. It lets us find the next term, right? We have the first term. We can start with the first term. We have the first term. Add the common difference to it. What's that going to give us? The second term. So we can find the second term by taking the first term and add the common difference. We can find the third term by taking the second term and add the common difference. We can find the ninth term by taking the eighth term and add the common difference. Well, we kind of already knew that, didn't we? I mean, that's just adding the common difference every time, right? That's what we were doing yesterday. So that's why I'm saying it seems a little bit redundant in that, but this is a format that is called recursive formulas, just like the quadratic formula, just like the distance formula, just like the midpoint formula. This is a way of algebraically writing, given a term, how can we find the next term in the sequence? That's what the recursive formula does for us. Everybody understand that?
Yes.
Does that make sense? Okay. Let's talk about what does a geometric recursive look like. So once again, got to start with the first term, right? Okay. And then once we know the first term, well, we can figure out any other term we want by taking the common ratio and multiplying it by the previous term. That makes sense, right? Common difference, we're adding to the previous term. Common ratio, we're multiplying to the previous term. So in this case, if we wanted to know the second term, we would take the first term and multiply it by the common ratio. If we wanted to know the third term, we would take the second term and multiply it by the common ratio. As long as we know the previous term, we can find the next term in the sequence. Recursive formula. Good so far? Make sense? Yep. Now, just want to emphasize again, both parts are needed in a recursive formula. You got to state your starting term, okay? And then you got to write your specific, we're just going to say ditto here, your specific recursive formula. I figured the best way was just to do some of these together. So let's do that. All right. So let's start with this sequence that we have right here. And we want to write a recursive formula. So that means it's got to be arithmetic or geometric, right? So which one is this? How do you know? Say that more algebraically.
The common difference.
Much. I like that. That's much better. The common difference is 5. So we'll just make a note that this one is arithmetic and it has a d of equal to 5. Okay. Why don't you try writing a recursive formula for this one? Let's see what you can do. Give it a shot.
Shall we shall?
All right. This is the recursive formula for that sequence. Take a look. See if it makes sense. It's a formula, right? Distance formula. It has a lot of variables where you plug in numbers, right? Pythagorean theorem formula, you plug in numbers, right? Quadratic formula, you plug in numbers. So what we're saying is the starting term in the sequence is 120. Okay? Any other number we can find as long as we know the previous term. Well, recursive only helps us find the next term in the sequence. So really the next place for us to go would be the second term in the sequence. If we've got the first term, the second term is the first term plus 5. Once we have the second term in the sequence, then we can find the third term in the sequence, because then it would be the third term in the sequence is the second term in the sequence plus 5. Right? Again, you can see where this tool is sort of limited in the sense that it only helps us find the next one, and we have to know the one previous of that. If we want to know the 175th term in the sequence, well, with recursive, we'd need to know the 174th term in order to apply the common difference. Get it? Does it make sense?
Yeah.
Okay. All right, let's work on number 2. Write a recursive formula for this one. Okay, well, then that means this sequence must be arithmetic or geometric. Why don't you write down something that looks like this for this one here? Let's see what you can come up with. All right, go ahead. Write down something like that. Let's take a look. You should have come up with something that looks like this here. Now, you shouldn't be using division. You should be using multiplication, right? Because it's a ratio. We're either multiplying by a number greater than 1, which would increase the numbers in the sequence, or multiplying by a fractional value, which would decrease the numbers in the sequence, okay? You could have been multiplying by 1/5, 2/10, 0.2. That's all the same thing. It's fine, okay? All right, write the recursive. Should have come up with that. Okay, neat writers. I'm not worried about you. You got this. My sloppy writers. Okay, you know who you are. All right, so here's the deal, okay? It is super important when you're doing these recursive formulas and other formulas where we're using this sub-notation that you make sure that it is clear that these are sub-notation. Because if you write this like this or like this, I will mark you wrong. That is not subnotation there. You cannot write it like that. You must make sure that you get that dropped down and that it's small and lower to the right. Just like you're writing an exponent, okay? So make sure, my not so neat writers, you do that. How we doing? Easy, right? Okay. Yeah, exactly. Okay. Let's use the recursive formula here to generate the first 4 terms of each sequence described by it. Now we're going the other way. Here is a recursive formula. Can you come up with the first 4 terms in the sequence? Go for it. Have come up with those sequences right there. Right, so you're starting with the first term, and then you're applying that next term common difference, or common ratio, either one. Right? And again, you know, I mean, this is sort of what we did the other day in the sense that it makes it pretty simple because, you know, we already get the idea of multiplying by 4, multiplying by 4, multiplying by 4, because we know that that's that common ratio. This is just the algebraic way of writing that, okay? But again, it only gets us that next term if we know the previous term. Pretty good? Yeah? Jack feels comfortable, I'm thinking? Yeah?
I think so.
All right. Let's take a look at a different type of problem.
I'm going to recycle that.
No. Jack. You got me?
No, I'm going to put it away.
I know you got this.
Whoa, warm door.
No. Doesn't smell fresh.
Is it fresh off the press?
Right.
You know what this means. More problems.
Yes.
Application stuff. All right. Here we go. So, Josie's received 2 job offers, both starting at $42,000 for the first year. A sub 1, $42,000. Okay. Company A will increase her salary by $4,000 per year, while Company B will increase her salary by 9% of the previous year's salary. Let's start with for each company. Let's write a recursive formula for Josie's salary in the year.
So we have common difference, which is common.
Okay, so what we need to do is find 9% of 42.
No, not to find a recursive.
It looks like that.
Oh, that is. No, I was right. You put 42,000. Yeah, you don't put it in the formula. It's just bow down to me.
All right. Let me highlight a couple of things for you. Let me highlight a couple things. Everybody watch up here, because I saw a lot of this. First off, in the notes we said that there are always 2 parts to every recursive formula every time you write it. So you should have 2 lines for every recursive formula. Line number 1 is, where am I starting? Usually the first term, first in the sequence. Line number 2 is, what math can I do given a term I know to find the next term? Where am I starting? What math do I do? Now think about this a second. Take a look at this one. When we're increasing the previous, okay, so what percent would we have to have of, what percent of year 2 will be year 2 salary if it was exactly the same as year 1? What percent would that be?
1.
1 or 100%, right? It'd be 100% of what you got year 1. But we want to increase that. In other words, we want to add to that 100%. So we want 100% and then 9% more, or 109% of the previous year. That's how you get this number to maintain the base 42,000 and add the 9%. And then the next number maintains the base of 100% of whatever that was and then adds the 9%. Does that make sense? 109%. Okay. Good? Makes sense? Okay, correct that on your paper so it looks like this. 2 lines, nice and neat, so it's clear on your notes so you have that as a good example to work with, okay? Now, there's really a lot of opportunity for you to think this through. Which company should Josie choose? And why? In your opinion, which company should she choose and why? Provide some evidence to justify your answer. Now listen, what did I just say at the end? Provide some evidence to justify your answer. Would it be a legit answer? What company should Josie choose and why? Well, her sister Marilyn works at the company and it'd be really great to work with her sister. So she should choose company A. Is that a legit answer to that question?
Yeah, no, because we don't know that.
Well, I mean, we don't know that, right? But I mean, it is a legit answer. It could be a reason why she chooses company A, right? But we can't provide evidence of that. The only thing that we have to provide evidence of is salary. So I guess the opinion is do you want to make more money? Do you want to make less money? Well, that's up to you to decide, but provide evidence to support that by showing how that's going to work out. Is it going to be the same amount? Does it matter? Is it always the same for both companies? Is one more than the other? Is one less than the other? You decide, show some evidence, and then write out an explanation. Okay? Go for it. Let's see what you come up with. My thoughts, and let's see how you did. This is what I said. I said, if Josie's planning on staying with the company 4 years or more, B is probably the best option financially because in my mind, the best option is to make more money. And then I showed what it would look like in the sequence starting at $42,000 using my recursive formulas and coming up with those numbers. And at the 4th year, it surpasses, company B surpasses company A, right? And then it's never going to get less than that after that, right? It's always increasing by more than 4,000, so there's no way that it could ever be lower than that. Now, these are sequences of numbers, right? But, I mean, a little foreshadowing for you. Maybe we're looking at something like this.
Never dies by like a year 100. She's making like stop.
Which one is which, and how do they work?
One's curved.
One's curved, one's straight. Constant increase. But additionally, versus multiplicationally, constant. Okay, anyway, just a little foreshadowing for you. All right, so the remaining problems on the paper are your homework.
Let's go.
You got 25, go.
Wait, what time are we out of here?
Both papers. Both papers. The remaining questions, so you got the 2-word problems, and then you have the remaining other questions. That's your homework. You got 25. Rock it out. Ready to go.
No, we all do it.